Okay, so the graphing lesson, okay, should be right in the stream first. Oh yes, of course, it's me, my password of all dots, just like everybody else's. Okay, so graphing lesson, that's the one we need to be in, and there is a Google Sheet there, okay, that you will need to open. Oh, did I not make it? Okay, I didn't make a copy for everybody. So here's what you're gonna have to do, everybody. Okay, you're gonna have to go File, make a copy. And it'll just say that, and then now you can edit it. All right, so we're gonna be using that file here in just a few minutes, okay, just to build line graphs with Google Sheets. How many people have done that before? Okay, I didn't think too many people would have. It's super easy, okay, but it is something that you'll use over and over and over again in high school, because this builds graphs way easier than by hand, okay, because building graphs by hand, well, is for primitives, and we are not that. So, okay, we're not going to do that anymore. Okay, so what's the purpose of graphs? What do they do for us?
Give us a visual of like what happens with anything really.
Yeah, they give us a quick visual reference of the relationship between two things. Those two things are always your manipulated variable and your responding variable. Okay? The manipulated variable always goes on the x-axis. Okay? There's a couple things you might want to write down as we go along here, guys. Okay? Your manipulated variable always goes on the x-axis. Your responding always goes on the y. That way, you can see if the manipulation you made had any effect or any response from the responding variable. Okay? So in this experiment here, what's the manipulated variable? Temperature. What's the responding variable? Rate of photosynthesis. Now, there's one mistake with this graph. Okay? The temperature in degrees Celsius. Up here, we got a good title, temperature versus photosynthesis. There's a label on the y-axis. It says rate of photosynthesis, but it's missing something. Units. Okay? Your graph should have labeled axes with units. Okay? I assume that this is in like milligrams of dissolved oxygen or something like that is usually what they use to measure the rate of photosynthesis, how much oxygen gets produced, okay, as a result. Okay? So what they saw here, okay, and this is the nice thing about graphs, is I can look at this graph and right away know that temperature does affect photosynthesis. Okay? And after a few more seconds, I can see that photosynthesis goes up with temperature until you get to about 30 degrees, and then it falls off pretty rapidly. Okay? And effectively, by the time you get to 37 degrees, which incidentally is body temperature, there's no photosynthesis at all. Okay? So does that tell me something important about the relationship between temperature and photosynthesis? Yes. It does. Okay? So a graph gives us that quick reference. I don't have to read through paragraphs of somebody's research about their experiment that they did to find out that as long as I keep plants less than 30 degrees Celsius, they're going to do okay. Okay? I can get that from this graph like that. Right? Everyone kind of follow me there? So that's the purpose of a graph, to quickly present or represent the data gained in an experiment. Okay? All right. So x-axis, the horizontal one, that's for manipulated variable. Y-axis, the vertical one, for responding variable. You need to have a title. You need to have labeled axes with units. Okay? Otherwise, the graph doesn't communicate very well. Okay? And then we're left kind of guessing as to what might the relationship be or what's even on the graph. All right. So what we're going to do here is we're going to build the graph that has to do with the number of sheets in a book, okay, and the thickness of the book. So if we go to our Google Sheet here, okay, you can see that one of the tabs at the bottom is book thickness. Okay, so I'd like you guys to go to that graph. I'm going to sit down because this is really hard to do with my finger on the touch screen. So I'm going to sit down and use a mouse and a keyboard. Okay, and so what we're going to do here, guys, is we are going to go to the first cell, so cell A1. Okay, put your pointer there, and you are going to click and drag until you've highlighted all of the data. Okay, now we want to build a graph, so we're going to go up to Insert. Okay, and if you click on Insert, you'll see that there's an option for Chart right down here. Okay, we want to insert a chart, so we're going to click on that. All right, when I do that, sometimes Google Sheets picks the kind of graph I want, sometimes it doesn't. Okay, so right over here in Chart Type, so if you see over on the right, there's a chart editor. Okay, this is where you're going to make all of your changes. Okay, so it says here scatter chart. That's actually what I want it to be, okay, because I can make a line graph from that. But it'll give me all kinds of other options, and they're not what I want. But okay, sometimes it picks the wrong one, and you have to go over here, and you have to pick the right one. Okay, scatter is usually the one we're going to want. Okay, now we want to do a few edits to this chart. Because of the way I set up my spreadsheet, I got labels on each axis and a title that's decent. Okay, now I don't have units necessarily written here, do I? But I also don't need it because the units are actually number. Okay, so like number of sheets kind of is the units. I don't really need to say number after that or sheets. Okay, it's kind of implied, okay, in that. All right, so I've got this graph set up the way I like it now. Okay, the next thing I need to do is within the chart editor. So if you did what I did and accidentally clicked away and lost the chart editor, go to the 3 dots right here and just go edit chart and it'll come back. All right, now what we're going to do is we're going to go to customize. So right beside setup, you'll see customize. You're going to click on that. Okay, this is where you can make all sorts of little changes and personalize your graph if you want to. Okay, so you could have your chart style. Okay, you could pick different colors for the borders. You can change the font. Okay, change the background color. Okay, but we don't really need to do that, so we're not going to mess with that. Okay, chart axis and titles is where you can change the titles. Okay, so maybe I want to change my title to just book thickness graph. Okay, that's where I would do it. Okay, and you can see it updates almost immediately as I go along. So now it says book thickness graph instead of number of sheets versus thickness. Okay, and in here again you can change your fonts, okay, all of that stuff if you want to. If you wanted to change anything about the axes, okay, you can either hover over them and then click on them and change it, or you can go here where it says chart title, and it'll ask you, you want horizontal axis title, vertical axis title, and that's where you can change them. Okay, we don't need to do that, right now, so we won't. Okay, so back in customize here. The next thing I want to go to is series. Okay, so I'm just going to click the drop down there. Okay, I only have one series, it's thickness. Okay, I can change, lots of things about this if I want to. I can change the color of my points. Pick any color I want. I can change the shape of my points. I can make them triangles. I can make them bigger or smaller. I like them small. Okay, totally up to you. Okay. Maybe for the triangles they're not as bad, so maybe 7's not bad for the triangles. Okay. Next thing I want to do is just pull this down a little bit. Okay, to where these check boxes are. Okay, so I've just pulled the scroll bar down to where I see these check boxes. The one I want to check is trend line, or what sometimes in math they call a best fit line or a line of best fit. Okay, so if I click on that, it's going to draw one for me, okay, which is an awesome feature because back in the day, you had to put a ruler on there and you had to guess if it followed the trend of your points well enough. So if 5 people made a graph of the same data, you'd have 5 different trend lines. Okay, and they'd all be reasonably valid. So this is much better because it's kind of, you know, AI powered maybe or something. All right, so we've got our line of best fit, and as soon as I click on trend line, I got a whole bunch of other options underneath. Okay, I do want it to be linear because that's what my points do. They are in a line. Okay, if I picked a different one, I could pick exponential, polynomial, logarithmic. Okay, I don't need those because that's not what I've got here. I've got a linear. Okay, you can change the thickness of that line if you want to, change its opacity, you can make it super dark or super light. Okay, this is the one we want though, right here on label. Okay, and we want to click on label because right now there's no label. And we want to click on that and use equation. Okay, and as soon as I click on that, I get an equation up here in the legend. Right? That we're going to use here in just a minute. Okay, is everybody to that point? All right. Okay, so I made that book thickness graph. Okay, this was my spreadsheet here. Okay, so the same one that we were just working on. And I got a graph that looked like this. And this is the equation that it spit out for me. Okay? Now, that equation is actually the graphing equation. Okay, or the equation for a linear function. How many people are in math right now? Okay, have you guys done y equals mx plus b, rise over run yet?
Started yesterday.
Started yesterday. Okay, well, awesome. You're going to get 2 for 1 every day for like the next week. Yeah, so you'll really know this stuff really well. Okay? All right, so any linear function is governed by this equation. Y equals m times x plus b. Okay? Y is the y value of any point on the line. Okay? So no matter where I am on this line, a y value has a corresponding x value. Okay? So that's what your y and your x are for in that equation. Okay? M is the slope. And B is your y-intercept. Okay? Now, your y-intercept is where your line, your best fit line, goes through or intercepts the y-axis. Okay, and we can clearly see on this graph that it does that at 5 millimeters, right? And our equation agrees. Okay, the place where that line goes through the y-axis is 5 millimeters. Okay, now here's what the y-intercept tells me. It tells me the value of y when x is what number?
0.
0. Okay? We're talking about the y-intercept here. If I go down here, x is 0. Okay? So it's telling me that a book with no pages still has a thickness of 5 millimeters. How's that possible? The cover, yeah. Okay? So the book's cover is 5 millimeters thick. Okay? Everyone all right with that idea? Okay. Now, the slope tells me something else. On every graph, the slope represents something different. Okay? On this particular graph, the slope is going to be in millimeters per sheet. Okay? Because it's y over x, right? The slope, the steepness of this line tells me how much y goes up for every move up for x. Okay? So for every sheet I add, the book is going to get 0.15 millimeters thicker. In other words, the slope is the thickness of one page. Okay? Does that make sense? All right. Now, on a different graph, that's still going to tell me how much y goes up for every increase in x, but it'll represent something different. Okay? In this one, it represented the thickness of a single page. On a graph that's showing distance and time, it would actually represent your speed. Because it would tell you how many meters you go every second, meters per second. Okay? On a graph of speed and time, it would tell you your acceleration, how much faster you go every second. Okay? Every graph's slope represents something else. And once you get the hang of it, it's not hard to figure out what the slope represents. It's always y divided by x. Okay? Everybody follow me there? Okay. So, if I'm using the equation for this line, could I calculate the number of sheets in a book that's 80 millimeters thick? Okay. 80 millimeters. What part of this equation is going to be the 80 millimeters? Y. What's on the y-axis? Millimeters. Okay, so if they tell me 80 millimeters, they've just told me, here's what y is. Calculate x when y is 80. That's what they're asking me to do. All right, now, according to my graph, if I know that y is 80, and I know that m is 0.15, and I know that b is 5, can I solve for x? Okay, do I have to do a little bit of algebra? Okay, let's look at the algebra then. Okay, so I've got y equals m times x plus b, and I'm trying to solve for x. What do I move first? B, it's not attached to x, rule number 3. Okay, algebra rule number 3. How do I move b over to the other side? Subtract it, okay. So I'm going to have y minus b equals m times x. All right? How do I get x by itself? Divide by m, right? Because right now I'm multiplying by m. If I want to move something, I do the opposite. Okay. Now I'm solving for x. Do I know all three of these numbers?
Yeah.
Yes, I do. Okay, so this is going to be 80 millimeters minus 5 millimeters divided by 0.15 millimeters per sheet. Is that going to leave me with number of sheets? Right? I'm going to have millimeters on the top, millimeters per sheet on the bottom. Millimeters are going to cancel and be left with sheets. Okay, that's what's on the x-axis anyway. So 75 divided by 0.15. Okay, that's a 500-page book. A 500-sheet book. I guess that would be 1,000 pages, because they would be double-sided.
It would probably be a bit less because there's always weird spare pages at the front and back.
Well, but we're not saying whether those pages have writing on them necessarily. This is just how many pages there are, right? It could be a blank book. Yeah. It could be like a notebook that you just bought and nothing's been written in it yet. Okay? All right, so we're going to have 500 sheets. Okay, everybody all right with that? Those are the kind of things you're going to be expected to do in both math, okay, and in physics here in science. Okay? All right, next one. Thickness of a book that has 805 pages. Okay, what did they just give me now? They gave me x. They want me to find? Is that going to be easier? Yeah, because the equation's already set up to solve for y, isn't it? I don't even have to do any algebra. I just have to plug numbers in. Okay, so for number 2, I'm just going to go y equals 0.15, my slope, m, times 805 pages, my x value, plus the thickness of the book with no pages, okay, the y-intercept, and that should give me the thickness of the book, right? So 0.15 times 805 plus 5. Okay, so it's going to be 125.75 millimeters thick. About like that. That's like War and Peace. Okay, that's a thick book. Okay. All right, everybody okay with that idea? All right, and then lastly, the number of millimeters per sheet. It's 0.15, okay, because that is our slope, okay, m, 0.15. Now, here's why that works, okay. If I manipulate this formula for m, I'm going to subtract b from both sides, right, that'll give me m times x, and then I'll divide both sides by x. Okay, so if I go y minus b, that's millimeters minus millimeters, so I still have millimeters, divided by sheets. Millimeters per sheet. Okay, gives me the thickness of the graph. Okay, that is the number that every y and x value have in common. Okay, this value of y and this value of x have that number in common. Okay, every value of y and x on the line have that number in common. Okay, that making some sense? Okay. I want you guys to see if you can build one of these graphs on your own. So I want you to go to the circles graph, the first one. Okay? See if you remember what I did there a few minutes ago. Okay? I'll give you a few minutes to try it on your own and then I'll quickly do it. Okay? So highlight the data, insert charts, okay? Make sure all the axes are right, put a line on there, put the equation on there. Here, sweet. Okay. So we're going to highlight it all. We're going to go to insert chart. Okay, it's going to give us the scatter plot that we want. Okay, it's got the labels and everything all right. So I'm just going to go straight to series, scroll down, make my circles a little smaller because I like small circles. Okay, I'm going to put the trend line on there by clicking trend line, and then I'm going to get the equation on there. Okay, my slope ends up being 3.1. If it had more decimals, it would be 3.141. Yeah, it's pi. Is that shocking, given what's on there? No. As the radius goes up, the circumference should go up by a factor of pi. Okay, each and every time. So, okay, those are perfectly valid numbers for us to get here. Okay, so now that we've got our circumference and diameter graph, okay, we know our slope. We've got a y-intercept. Should we? I mean, really, if this was 100% accurate, I should have a y-intercept that is 0, because a circle with a radius of 0 would also have a circumference of 0. Okay, so there's a little bit of error in this, and it's mostly because of the numbers I picked. I rounded them off. Okay, pi never ends. Okay, since pi never ends, okay, I should actually have slightly different numbers here, and then I would actually get a y-intercept of 0. All right, so here is what I would like you guys to have a look at next. Okay, okay, so circumference of a circle with a diameter of 0.88 meters. I take 0.88 and I multiply it by the slope, which is 3.1, or I multiply by pi. Okay, and I get it. And then the diameter of a circle whose circumference is 41.5 meters, well, then I divide that by pi. Okay, and technically I would also subtract the 0.149 from the 41.5 first. Technically speaking, I should do that. Okay, but obviously for this we wouldn't have to. Okay, the next one I want you guys to do is, I want you to do the rubber band and force graph. Okay, so rubber band graph here. Okay, I want you to get that graph built, and then we'll look at the questions that I'll have up on the board here to go along with that one. So I'll give you about 3 minutes to get that graph built, because that's about all it should take. Okay, so using this, okay, this is the issue I have with Google Sheets. They never do this. They never say y equals, but it is. Y equals, okay, 2 times x plus 6.5. Okay, so use that equation, answer those 3 questions. So, how long will the rubber band be if it's stretched with 15 newtons of force? What did they give us there, y or x? They gave us x. Newtons and force are on the x-axis. Okay, so we know that we are looking for y because y is length. How long is length? So, okay, we're going to try and find that right now. Okay, and we're going to say that that's going to mean 2 times 15. Okay, our x value plus 6.5. All right, so that should be 36.5, right? 36.5 centimeters. Everybody all right with that one? Okay. What force is needed to stretch the band to a length of 18.7 centimeters? What did they give me? They gave me y, centimeters, length. Okay, they want me to find force. That's on the x-axis. Do you guys follow the kind of thought process we need to go through for these? Okay, so I need to take this formula and I need to manipulate it for x. So I'd subtract b from both sides and then divide both sides by m. That'll leave me with x. Okay, plug in my numbers. 18.7 minus 6.5 divided by 15, right?
2.
No, by 2, sorry. 2. All right, so what do we got there? 12.2 divided by 2, so 6.1. Is that right?
Yeah.
I did math in my head this morning. Okay, 6.1 newtons, okay, would be the amount of force that I would need to stretch that rubber band. Okay, last question. Does this involve any calculating? Nope. The answer is right there in the equation. How long is the rubber band when it's not stretched? Okay, stretching involves applying a force. If I apply no force, how long is the rubber band? 6.5 centimeters. Okay, that's the y-intercept. It tells me the value of y, length, when the value of x, force, is 0. Okay, Alex?
On the graph on Google Sheets is meters, not centimeters.
Oh, okay. I probably just forgot to change it. Okay. All right, questions on how that works? Okay, on Monday, I think it's Monday, I have these Chromebooks booked again. We're going to be doing a lab on position and time. Okay, we're going to do a little lab there and make some graphs with that. Okay? All right, I need those Chromebooks shut down, close the lid, and put them back in the right slots, please, and plug them in.